All right, so let's look at the different cases of different number of equations and different number of unknowns. So it's really important to keep context. So you know that if I have 3 equations and 3 unknowns, that it's possible to have a unique solution, right? So if I've got 2 unknowns and 4 equations, I can have a unique solution. So let's just double check and see what I mean. So 1 and negative 2, 1, 2, negative 4, 2, negative 3, 9, 6, negative 1, 3, 2. All right, so let's do some row operations. So let's take and multiply negative 2 times row 1 and add it to row 2. So 0, if I multiply negative, so that gives me a 0, and that gives me a 0. Oh my goodness, okay. So then if I multiply row 1 by 3 and add it to row 3, so I'll get a 0. Multiply by 3, negative 6, so that gives me a 3. Multiply by 3 and add, so that gives me a 9. And let's just add these first 2 rows, right? So row 1 and row 4, so I was trying to say, sorry. So add them and get 0, add them and get 1, add them and get 3. All right, so with echelon form, we always want to move the row of zeros to the bottom. So let's do that. Okay, so let's multiply row 2, whoops, write that again, row 2 by 1/3. Multiply row 2 by 1/3. So I get 0, there we go, 1, 3, 0, 1, 3, 0, 0, 0. Oh my goodness, I think I can just negative 1 times row 2 and add it to row 3. So, not 0. 1, negative 2, 0, 0, 1, 3, 0, 0, 0, 0, 0, 0. Okay. So let's think about this. Rows of zeros sometimes means there's more than one solution. But if I take this row and let's finish it off and put it in RREF, so 2 times row 2 and add it to row 1, that gives me a 0. No, sorry. Get a 1. The 1 stays here first. 2 and add this, that gives me a 0 there. 2 and add, that gives me a 6. 0, 1, 3, 0, 0, 0, 0, 0, 0. So let's decode what this means. So this first row means x1 is equal to 6. The second row means x2 is equal to 3. There's only 2 unknowns. So these 2 rows of zeros just meant there was extra material. So rows of zeros do not necessarily mean infinitely many solutions. Okay, so let's look at this example. Here I have 2 equations and 3 unknowns. So when I put that together into a matrix, 0, 1, 1, 3. Okay, so this is a pivot. It's got a 0 below it. This is a pivot. I want to get a 0 above it. So if I multiply row 3 by 3 and add it to row 1, I'll get a 0 here. Multiply by 3 and add, I'll get a negative 2. Multiply by 3 and add, I'll get a 9. Okay. So let's decode what this means. So this first row here means x1 minus 2x3 equal 9. The second row means x2 plus x3 is equal to 3. So we always solve for our pivot. Our pivot positions are our basic variables. More definitions. So if I solve for x1, I get this. If I solve for x2, I get this. So this is our x1, this is our x2. Our x3 is what we call a free variable. So it's free. So this is our general solution, and this is showing how I get infinitely many solutions because I'm allowed to choose anything for x3.